Our solar system is like a big family. It has the sun, planets, moons, and many other objects. All these things are in space, going around the sun. We live on Earth, which is one of the planets in this family. The sun is in the middle, and everything else goes around it. It's like a giant dance floor, with the sun playing the music. Some things are closer to the sun, and some are farther away. Our solar system is a busy place, with lots of activity happening all the time. Learning about the solar system helps us understand more about space and where we come from. Imagine a huge cloud of gas and dust floating in space. Billions of years ago, our solar system was just that. This cloud, called a solar nebula, was like a giant construction site. Over a very long time, gravity started to pull this gas and dust together. It all clumped up in the center, becoming hotter and denser. This clump eventually became our sun. The rest of the gas and dust swirled around the newborn sun. As it spun, it flattened into a disk. Small particles stuck together, forming bigger and bigger objects. This is how the planets were born. The sun is the heart of our solar system. It's a giant ball of hot gas that gives us light and heat. Without the sun, there would be no life on Earth. The sun is so big that you could fit over 1 million Earths inside it. It's incredibly hot, with a surface temperature of about 5,500 degrees Celsius. That's hot enough to melt anything. The sun is a star, just like the ones we see in the night sky. It produces energy through a process called nuclear fusion. This energy travels through space and reaches us as sunlight. The inner solar system is where the rocky planets hang out. These planets are Mercury, Venus, Earth and Mars. They are the closest planets to the Sun and have unique characteristics that set them apart from the gas giants in the outer solar system. These planets are made up mostly of rock and metal. Unlike the gas giants, which are composed mainly of hydrogen and helium, the inner planets have solid surfaces. This makes them more similar to each other in terms of composition, but they still have distinct differences. They are much smaller than the gas giants. For instance, Jupiter, the largest gas giant, is more than 11 times the diameter of Earth. This size difference is significant and affects many aspects of the planets, including their gravity and atmospheres. Mercury is the smallest planet and the closest to the Sun. It has a very thin atmosphere, which means it cannot retain heat. As a result, temperatures on Mercury can swing dramatically from extremely hot during the day to freezing cold at night. It's a scorching hot world with a cratered surface. These craters were formed by impacts from comets and asteroids. Despite its harsh conditions, Mercury has been a subject of interest for scientists studying the early solar system. Venus is the hottest planet, even hotter than Mercury. This is due to its thick atmosphere, which is composed mainly of carbon dioxide. The atmosphere creates a runaway greenhouse effect, trapping heat and raising surface temperatures to over 900 degrees Fahrenheit. It has a thick atmosphere that traps heat. The clouds of Venus are made of sulfuric acid, making the planet's environment extremely hostile. Despite these conditions, Venus is often called Earth's sister planet because of its similar size and composition. Earth is our home and the only planet known to have life. It has the perfect conditions for life as we know it, including liquid water, a stable climate, and a protective atmosphere. These factors have allowed a diverse range of life forms to thrive. It's a beautiful blue and green planet with oceans, continents, and an atmosphere that protects us. The atmosphere not only provides the air we breathe, but also shields us from a harmful solar radiation and helps regulate the planet's temperature. Mars is the red planet, named after its rusty red surface. This coloration comes from iron oxide or rust on its surface. Mars has been a focal point for exploration due to its potential to have once harbored life. It's a cold, dry planet with signs of ancient water. Evidence of river valleys, lake beds, and minerals that form in water suggests that Mars may have had a wetter and warmer climate in the past. This makes it a key target in the search for past life in our solar system. Section 5. Gas giants, Jupiter and Saturn. These two planets are the titans of our solar system, both in size and in their fascinating characteristics. Now let's move on to the outer solar system, where the gas giants live. This region is home to the largest planets in our solar system, far beyond the rocky worlds closer to the Sun. These planets are much bigger than the inner planets and are made mostly of gas. Unlike the terrestrial planets, which have solid surfaces, gas giants like Jupiter and Saturn are composed predominantly of hydrogen and helium. Jupiter is the largest planet in our solar system. It is so massive that it could fit all the other planets inside it and still have room to spare. It's a giant ball of gas with a swirling storm called the Great Red Spot. This storm is so large that 3 Earths could fit inside it, and it has been raging for at least 400 years. Jupiter has many moons, some of which are even bigger than the planet Mercury. The 4 largest, known as the Galilean moons, are Io, Europa, Ganymede, and Callisto. Each of these moons is a world of its own, with unique features and mysteries. Saturn is famous for its beautiful rings, which are made up of ice and rock. These rings are incredibly complex and consist of thousands of small ringlets, creating a stunning visual spectacle. Like Jupiter, Saturn is a gas giant with many moons. In fact, Saturn has over 80 moons, each with its own unique characteristics and stories to tell. One of its moons, Titan, has a thick atmosphere and even lakes of liquid methane. Titan is the only moon in the solar system with a dense atmosphere, and its surface is dotted with rivers, lakes, and seas of liquid hydrocarbons, making it one of the most intriguing places in our solar system. The Cassini spacecraft, which orbited Saturn for over 13 years, provided us with a wealth of information about this gas giant and its moons. Its mission has greatly expanded our understanding of the outer solar system. Occasionally, Jupiter and Saturn come close together in the sky in an event known as the Great Conjunction. This rare alignment, which happens roughly every 20 years, offers a spectacular view for skywatchers on Earth. The Voyager spacecraft, launched in the late 1970s, provided the first close-up images of Jupiter and Saturn. These missions paved the way for future exploration and deepened our fascination with these distant giants. Even today, amateur astronomers can observe Jupiter and Saturn with a simple telescope. Their bright presence in the night sky continues to inspire wonder and curiosity about the vastness of our solar system. Section 6. Ice giants Uranus and Neptune. Farther out in the solar system we find the ice giants Uranus and Neptune. These 2 planets are the 7th and 8th from the Sun, respectively, and are known for their unique characteristics and striking blue hues. These planets are similar to the gas giants, Jupiter and Saturn, but are much colder. Unlike the gas giants, which are primarily composed of hydrogen and helium, Uranus and Neptune have a higher concentration of ices, such as water, ammonia, and methane, giving them their classification as ice giants. Uranus is a strange planet that spins on its side. This unusual tilt, at an angle of about 98 degrees, means that its poles experience extreme seasons, with each pole getting around 42 years of continuous sunlight followed by 42 years of darkness. It has faint rings and a blue-green color due to methane in its atmosphere. The methane absorbs red light and reflects blue and green light, giving Uranus its distinctive hue. The rings of Uranus are dark and faint, making them difficult to observe from Earth. Neptune is also blue because of methane, but it has a more dynamic atmosphere with strong winds. In fact, Neptune has the fastest winds in the solar system, reaching speeds of up to 1,200 miles per hour. These winds create large storms, including the famous Great Dark Spot, which is similar to Jupiter's Great Red Spot. Both Uranus and Neptune have many moons and are thought to have slushy ice deep inside. Uranus has 27 known moons, with the largest ones being Titania, Oberon, Umbriel, Ariel, and Miranda. Neptune has 14 known moons, with Triton being the largest and most interesting due to its retrograde orbit and geysers of nitrogen gas. These planets are very far away and difficult to study, but scientists are learning more about them all the time. Missions like Voyager 2, which flew by Uranus in 1986 and Neptune in 1989, have provided valuable data. Future missions and advanced telescopes may reveal even more about these distant, mysterious worlds. Section 7. Dwarf planets and other celestial objects. Beyond the 8 main planets, our solar system is home to many other objects, including dwarf planets. Dwarf planets are smaller than planets, but bigger than asteroids. Pluto is the most famous dwarf planet. It was once considered the 9th planet, but was reclassified in 2006. Other dwarf planets include Ceres, Eris, Makemaker, and Haumea. Asteroids are rocky bodies that orbit the Sun. Most asteroids are found in the asteroid belt between Mars and Jupiter. Comets are icy bodies that release gas and dust when they get close to the Sun. Section 8. The Kuiper Belt and beyond. The Kuiper Belt is a region beyond Neptune that is home to many icy objects, including dwarf planets. It's like a giant cosmic refrigerator. The Kuiper Belt is thought to be the source of short-period comets which have orbits of less than 200 years. Beyond the Kuiper Belt lies the Oort cloud, a theoretical cloud of icy objects. The Oort cloud is thought to be the source of long-period comets, which can take thousands of years to orbit the Sun. It's a mysterious region that we're only beginning to understand. Section 9. Moons with potential for life. While Earth is the only place in our solar system known to have life, there are other places that might be habitable. Some moons, for example, have conditions that could potentially support life. Europa, a moon of Jupiter, is one such place. It has a subsurface ocean of liquid water, which is thought to be more water than all the oceans on Earth combined. Enceladus, a moon of Saturn, is another promising candidate. It has geysers that erupt from its south polar region, spewing water vapor and organic molecules into space. These moons are exciting targets in the search for extraterrestrial life.